thing. It will display only the unique values, okay, and in that column. And next is some exercises, okay. Here the column dt day has been read as object data, but on the other hand it should be of date type. How would you convert values object type in column dt to date time data type, right? So we discussed this one in the previous session, how to convert the date time, right? So you have something called date time library that is available. Import date time, right? After importing that, you can convert this dt date into date time, month and all, okay. Just give it a try, okay, and then probably I will come back to in the next I'll come back with the answers for these questions in the next session. So other one is univariate analysis. So we discussed about univariate and bivariate as part of descriptive statistics session, right? So what is univariate analysis? You are performing analysis on all the columns, okay. Here if I give my data frame name dot describe, right, it works for univariate analysis. You will perform it for continuous variable. What is continuous variable? Can someone type me in the chat window? What is continuous variable? Here you can find out here, right? So season and year, what is the count? How many number of seasons are there? How many number of years are there, right? The number of years of transactions, right? And then mean. So this is the mean value, average, right? So average value, standard deviation. For each and every column, it performs, you know, this kind of arithmetic operation. First quartile, median, and then third quartile. This is the value it will extract, and then maximum value, minimum value, right? So maximum value 1, 2, 3, 4. Here you have 4 number summary, and then along with that you have 5 number summary. Along with the 5 number summary, it displays the standard deviation also, and also count. It displays the count also, right? If you use describe, it will perform the summary statistics. Next we will see, so you have a column by the name of temperature, right? So you have a column called temperature, right? If I wanted to see the distribution of temperature, right? So how do you find out the distribution of your data? So you can use histogram, right? So train of data is my data frame name within the bracket and specifying a specific column temp dot hist bins equal to 50. That means, you know, you will create 50 bins, okay, and then you will plot the data. Now we can see whether the data is asymmetric or symmetric, right? So more bikes are rented when the temperature is average. So here in this case, right, so we can find out, so this is the one it tells the story, right? So more bikes are rented when the temperature is average, right? One second here, I have some guest here. 1 second. Yeah, I'm back. So you guys are there, right? Okay. So just by plotting this, right? So it tells us the story, right? We can see that more bikes are rented when the temperature is average. This is like, you know, bike related data. So basically we wanted to explore, you know, how the bikes are rented. So they are, you know, there is a shop, they are a company, okay, they are the one providing the bikes on a rental basis, right? So when they plot it, what kind of inference they can make it from here is when the bikes are, more bikes are rented when the temperature is average. When the temperature is too hot or too cold, right? So they are not, you know, renting more bikes here. See here, the temperature is, you know, very high and temperature is too low here, right? So in that time, if you see the number of bikes rented is very less. So here, if you look at it, you know, it's an average temperature when the temperature is average, right? So this is, you know, cold and this is hot, right? So here, when the temperature is not so cold and not so, when the temperature is not so high, right? This is very high temperature here, okay? So average, when the temperature is average, most of the people are renting the bikes very high. See how the data tells the story, right? So just all you have to do is just plot the day temperature. With that you should be able to identify that one. Okay. And also I have given the link also. With the help of the link you can look at for further reference, okay, how the box plot. Now, so this is my histogram, right, visualization. Okay, I wanted to visualize with the help of histogram, hist command, and again you can specify the bins, how many number of bins that you needed. Okay, instead of using histogram, if they wanted you to plot it using box plot, right, box plot is meant for what purpose? To visualize the 5-number summary, okay. So here when you plotted box plot, right, column you have to specify which column you wanted to plot a box plot, registered, right. So this is what your median, this is your first quartile, this is your minimum value, maximum value, right. So this is the registered column, right. So from this plot what we can understand, so number of right, so here there are some values which don't lie in the normal range of values. See, if you look at these values, right, these are all kind of outliers, right. So this is the minimum and maximum. These values, that don't lie in the normal range of values. Why is it so? Because few hours the number of registered users is too high. Sometimes the number of registered users are very high, right. So than the usual. Okay, so that is what it shows. Okay, registered. Okay. See, you don't have to do the minimum, maximum, all the things like how you do it in normal ETL process or normal the report developers, right. So you are a data scientist. So when you just by plotting this itself, we can tell the story, right. You should be able to understand the story. That's why the story also available here. Next one is categorical variable. Okay, we will use frequency table, right. So to understand distribution of each category, either you can use histogram to understand the pattern of the data, or you can use the frequency table also, right. So train data, season, value counts. So here you can specify the frequency also, right. So here there are comparatively more values of season 1 and 2. For season 1 and 2, more number of values are, but seasons 3 and 4, the more values of seasons 1 and 2 than seasons 3 and 4. Compared to these two seasons, the values are very less. Maybe these two seasons are average, having average temperature, right. So and here the temperature is not so good. So that's the reason why most of the users are going by in this season only. The sale is very high, the rental is very high. So next, these are the exercises. Humidity with the bin size equal to 100. Box plot of humidity, and then segregate the plot by season. Okay, univariate analysis also used to highlight missing and outlier values in the displays the frequent, right. So this is how you can try these exercises. Day 3 exercise you can try it out. Okay, same way histogram, but only thing is here plot by season. Draw a box plot of humidity and then segregate the plot by season. This you give it a try, right. So to refer that one, right, you can use Google also, and then you need to create a frequency table for year column. That also you try it out. Next is bivariate analysis. Okay, bivariate, if I have to compare the categorical versus continuous and continuous, categorical versus continuous, categorical versus categorical, right. In that case you can do bivariate analysis. Here I am creating a scatter plot. Scatter plot, as I discussed the descriptive statistics session, right. During the descriptive statistics session I discussed about the scatter plot, right. If you wanted to perform any analysis between two variables, bivariate analysis, then you can use scatter plot. This is in x-axis, right. So in the x-axis, this is your x-axis, this is your y-axis, okay, and temp and then a temp, right, x and y, right. So it will get plotted. With that, you can find out are there any correlation between these two variables, right. To find the strength of the we use correlation. So if here a correlation between correlation values lies between -1 +1. If it is 0 means there is no correlation. Okay, so this is the command that we'll be using it, cor function. Train data, This is the column. Which column I wanted to find out the correlation? Correlation with train data item. This column, temp column, I wanted to find out the correlation. This is the column, right? Temp with itemp, I wanted to find out the correlation. Okay, behind the scene, as part of scatter plot, this is what is done. But still, using correlation, this command, we can get the number value. How strong the relationship between these two variables, right? That you can find out here. Next one is, see, now we have compared the continuous variable with continuous variable, right? Next one is, we are comparing the categorical and continuous. So here the categorical is season, right? And season, and column is temperature, right? So this is the thing, right? So earlier one exercise was there, right? You need to create a box plot based on a column, and then you need to segregate it based on the season thing, right? This is the thing. This is the answer for that. Okay. Box plot grouped by season. So season 1, season 2, season 3, season 4, 4 seasons are there. Each season, what is the temperature, right? That is what we are plotting it here. Highest in season 3 and 4, if you look at it, season, okay, highest in generally the temperature is high in season 3. That's what we can see, right? So season temperature, right? So temperature is very high, and lowest in season 1 compared to other box plots, right? So this is very less. The minimum value is very less, and even the maximum value is almost closer to the the median value of other box plots. So probably season 2 and 3 would be favorable for biking. You are able to understand, right? Vinod and Rupa? Hello? How about Vinod? Vinod, are you there? Okay. Now, so far we discussed about the continuous and categorical continuous, and then now we will see categorical and categorical. If I have two categorical variable, let's say something I have okay, hour, working day hour. See the index, I'm just overriding the default index value here, right? The index is hour here. Instead of relying on the 0, 1, 2, 3 index number, I'm just using the hourly index here, okay? And I'm doing aggregation also based on the I'm taking the mean for this column, okay, hour, okay? Each hour, what is the average hours they have hired the bike, and this is one of the this is one of the pivot table, okay? How to create a pivot table, that is also possible with this one. See here, I'm just giving the count, okay? Hourly count, okay? Hour, right? So hour, in 0 hour, okay, how many of them have 0 hour? In the sense, what does that mean here? Is there anything like 0 hour? Sorry, it is not actually 0 hour. This is an index, okay? Row number 1, row number 2, like that, okay? In row number 1, right? So the total count is 0. None of them hired the bike, okay? How many of them have hired the bike, right? So if you add these two things together, it will something, yeah, it will, okay, it will, we are not supposed to add it. It will go way beyond this, okay? And then we are taking the count of values, and then on top of the count of the values, we are taking the mean value here. You try just with count alone, remove aggregate function and try with this one and compare with this one. That is another exercise, okay? Next one is stacked bar chart. Okay, I wanted to have stacked bar chart, right? So you have to use this plot. Already we have it, right? So this is what our it's not a plot, sorry, it's a pivot table. This is the pivot table, right? I wanted to plot the pivot table's content in my by this one, box plot. Box plot, how do you specify? Plot command. Sorry, not box plot, bar chart. This is bar chart, and this is what your box plot. Box plot, it is pretty straightforward. You have to specify box plot. If you just specify plot, right? So temp dot plot and kind equal to bar. it will be a bar chart, and stacked equal to 0. Working day, when the working day is, this is working day is 0, and that means non-working day and working day, right? What is the, I wanted to find out during the working day how many of them are renting the bike, non-working day how many of them are renting the bike, right? So with that we should be able to get a clear understanding. If you look at it, right, so if you take only these three charts, right, so these three these bar charts, these group of bar charts, if you take, if you look at it, right, so majority of the time we can see that during non-working day they are renting the bike a lot compared to your working day, right? But here but there are certain things are quite contrary to these things, right? But if you look at these two days, right, 17th and 18th, compared to non-working day, right, so the most of them they hired the bike during the working day only. But overall, if you look at it, we can find the mixed opinion, we can gain the mixed opinion. So here if you look at during working day, many of them rented the bike, here also rented bike. But here if you look at it, but overall if you look at it, compared to working day, non-working day, the bike rental is very high here. What inference can we gain from this? The plot shows an hourly distribution of count of rented bikes, hourly distribution, yeah. It is then color coded with respect to distribution working versus non-working days. Okay, if you check, what we are doing is we are taking 1 month data or so, right, and then 24 hours are there per day, right? We are doing some kind of aggregation, right? So each and every day, let's say in 18th hour, how many of them have hired during work hours, working days and non-working days. Okay. Spikes of rented bikes on working days. Okay, during the working day we can see the spike on rented bikes. Okay, yeah. The plot shows a surge in count at hour 8 and then hour 17 to 18. 17 to 18 and 8th hour, we can see the increase in this trend. People might be returning from work at that time. Okay, so whosoever going to office and while coming back from office, right, they go and rent the bikes. So in US and other countries, right, what they do is they rent the bike also. So before going to office, you can take the bike, and then probably once you reach your office, you can call that person, they will come and pick up the bike. Okay, after you leave your office, right, you need a bike to reach your home after office hour, right? So in that case, what you can do is you can call them, or you can go to the nearby rent a bike showroom. You can shop. You can take the bike for rental purpose, and you can come and reach your home. This plot shows a surge in count at which all hours we can see the surge in the rental bikes, right? So apart from these two times, the rest of the times are like non-working days. The rental is very high compared to working days. Now you need to find the correlation between temperature and humidity. Already right? The column data frame name dot the column name dot core function you have to specify. And then if you want to compare in the case of correlation, you need to compare with one variable with another variable, right? So here the temperature is temp and humidity is hum, right? So here if you compare this one, what will happen is it will get correlation, right? You need to use the correlation command. So core function on which column, and then within the bracket you need to specify the data frame name comma the column name. That needs to be compared. Okay, those things, and then pivot table also you try it out. Okay, so these exercises you can write out. It's all very simple, but data exploration part is very much important. I will probably, one second, let me share the data also. Train.csv is not the right. I will share the data also. You can just play around with that. Okay. Next one is day 4 exercise.ipynb. This is another IPython notebook. Okay, missing values. Okay, impact of missing values, how to detect missing values. So isNull function will help you to find out the missing values from your data frame. Okay, and then okay, it displays missing values. Which function? Data frame name dot isNull function which displays the missing values. Wherever you can find true, that means that in that particular column, for that particular row it has a missing value. So look here, I highlighted it here. Okay, true. What is true here? So if you look at this column, that means here you have null value in it. Absences column, first these two first two rows for absences column you have null values, missing values. It displays in the context of Boolean value, right? What is Boolean value? True or false. So what is true here? Values are missing for for this column in these two row, right? Similarly, you will have to find out for other columns. Here the value is missing for absences, right? Any other true value you can find it here. Here we can find out another true. That means family relationship column has missing values in this particular row, 26th row, right? So missing values. Now I need to find out the total number of missing values. Instead of going line by line, how many missing values, 1 to each column, what is the missing values? Data frame name, this is my data frame name, data dot isNull function dot sum function will count the number of missing values. See, activities you have 84, rows you have missing values, family relationship you have 117 columns you have missing values, absences you have 58 columns missing values. Okay, which are methods to treat missing values? How do I delete the missing values? Now we were able to find out the missing values using isNull function, and also we can find out how many number of observations, which is nothing but the records having missing values for the column level, right? That's what we have. Now the next step is, just by finding the missing values is not sufficient. We need to treat the missing values, right? And there are two options. One is deletion and imputation. Deletion is very easier. Whichever columns are missing, right, missing values in it, you can simply drop those columns. See, this is the command, data dot drop NA, how equal to any. If I give any, it will drop all the missing values related observations from your data set, right? So the one drawback with this deletion is, right, so in general when we perform any statistical analysis, what will happen is we are we are getting only the sample may be 1000 records, or maybe 1 lakh records, or maybe 20,000 records. Already in the case of 20,000 records, I have only 20,000 records, but my customer is running a largest retail chain. Unfortunately, I was able to gather only 20,000 records as part of my sample. Okay, my sample size is all very small, and on top of that I can see a couple of columns having missing values like this. Okay, if I remove this, right, what will happen? These 58 records will get deleted, again another 117 record. If these two columns have a overlap, let's say absence column has missing value and also family relationship has missing value, if you delete it, then not many records will get deleted. But if the absences record is having the absences column having a missing value, and family relationship does not have a missing value, right? In that case, what will happen? 58 records will get deleted, again 117 records will get deleted for your family relationship. If you add all the things, right, and then if you simply delete it, your 20,000 records that are part of your sample will get reduced, right? So ideally your sample size should be reasonably big, right, reasonably good. So, your size should be reasonably good. If you reduce it, what will happen? Your sample will have a biased one, right? There could be chances it will have a biased information. So right, so that's the reason why dropping the null value is not the suggested approach. Instead, what you can do is null we have count, right? So let's say in this case what I did, I simply use this command data dot drop any, how equal to any. So what it does is it will remove all the columns along what are all the observations that are related to the columns that have null values in it. So if you select this now, result dot is null dot sum function, you will find 0 0. That means there are no, after removing the null values related observations, right? So now I am checking it, are there any more null values are there, or all the null values got removed? Yes, all the null values got removed. We don't have any more null values. We don't have 0 means we don't have any null values. It is not that we have zero records. We have data in it, but what it says is we don't have any null values in these columns. It has data in it. That is what it says. Now I am just printing before and after. Before data dot shape will display, what is the shape command will do? Number of rows, number of columns. After, result dot shape is the one. Result is the one holding the the removed null values in it, right? So if you can, so after removing the null values from your data set, the number of observations comes down to 182, number of columns comes down to 32. Column remains same, but the so next other approach is here. So we discussed about deletion, right? So deletion, if I delete the rows that have null values in it, the rows that have null values in it, right, the number of records got reduced, right? This is not the right way of doing it. If the number of values are very less, for example, instead of 182, if the records are something like 385 or 390, then it is fine, because only few columns or few rows have missing values in it. Removing those columns does not have major impact. But in this case, right, it is almost 50% of the data. 182 plus 182, how much? 200, 364, right? Almost 55% of the data that you deleted it. This is not the right way of doing it. Instead, we have another approach called data imputation. Whichever column has missing value in it, I am going to replace that with some mean value of that column, right? Take for example data dot absences. Take this column absences, right? So here we can see the head. First 5 records it displays, right? Head command by default, head function by default displays 5 records, 0, 1, 2, 3, 4, all 5 records, right? So first 2 records for absences, we can find out null values in it. That's what we have seen it here, right? Absences, look here, absences, first 2 records, you have true, true. That means these 2 records for absences have null values in it, right? The rest of them we have data. The remaining 3, not the rest of the entire data. Okay, here, right? So you have data here. Now I'm filling this one with, I'm replacing this null values by taking the mean value of the entire absence column, and then I'm filling at this one. Okay, data. So now what I do is data dot absences. 1 second. Yeah. So data, which column I want to do data imputation. What is data imputation? Data imputation is nothing but you are filling the missing values columns values. Okay, that is what your data imputation is all about. Okay, data absences column, right? This is the column I found some missing values. I need to replace these missing values by taking the mean value of my absences column. Entire absence column I am taking a mean, and then I am filling those filling those null values. Okay, null value is not a number. NaN is nothing but not a number. Okay, after filling the mean value, wherever the missing values are there, I am just using the result dot head function to check whether this value got replaced or not. Yes, these values are got replaced. The mean value for the absence is 5.866. I think we have done describe already. No, we have not done, right? So by ideally you can do describe function before you start do this one, so that you will come to know. You can compare these two things. So 5.8 is the mean value for your absence column. That is the one replaced in the place of null values. That's how we have done it. So that is for your numerical value. In the case of absences, right, this is a number of days absences, something like, right? So this is a numerical value, which is nothing but your continuous variable. let's say I have something called qualitative variable, categorical variable. So in that case, how do I, if I find any missing values, how do I replace that one? In that case, you have to use mode function. Okay, data dot activity is a qualitative field. Either you will find either yes or no values in it. Okay, right, yes or no values. So in that case, there are few columns I have missing values in it. Right, mode function. I'm taking the mode of the thing. First column alone. Yes is there, first row. Okay, and result fill NA. Right, so mode I'm taking and then fill NA for the activities wherever the null values are there. Take the mode and fill that one. So now if result dot is null sum, nothing is there. Right, data dot activities dot head. Now if you see that, so you have no here you don't see any null values, NaN is not there. Okay, right. Similarly for family relationship also you impute the missing values. Right, so this is an exercise for you, only one exercise. Compare my previous thing and then you can do it. Okay, so don't get confused with this NaN because I made some changes here. Okay, probably you can check this one once again. Okay, mode instead of taking only one value, remove this 0 thing and then try with the mode for entire column and then you can try it out. So that way you can remove this one also. This is an exercise, you can try this one. Okay, and impute missing values for this one. Next we will see what is outlier. Outlier is nothing but the excessively higher value or very low value. Okay, that is what your outlier. So the various reasons for the outliers, either data entry, typing mistake or measurement error, wrongly we are measuring it. Okay, and experimental error and intentional outlier. For example, in the case of intentional outlier, right, teens are more likely to underreport the amount of alcohol they have consumed. Only a fraction of them will reveal the actual quantity. Here the actual quantity might look like outliers because the rest of the teens are underreporting the consumption. Right, intentionally they have not revealed the fact that they consumed alcohol. Right, so this is the intentional outlier. And data processing error and sampling error, natural outlier. Just go through this one. Right, impact of outliers. What is the impact of outliers? If I have outliers in my data set, what will be the impact? It increases the error variance and reduces the power of statistical tests. This we will look at it when we start building the model. I'll explain you. Okay, with outlier, how my errors are spiked up. Okay, how it reduces my statistical test power. Okay, that we will see. If the outliers are non-randomly distributed, they can decrease normality. They can bias or influence estimates that may be of substantive interest. They can also impact the basic assumption of regression, ANOVA and other statistical model assumptions. To understand the impact deeply, let's take an example to check what happens to data with and without outliers. So this is the thing. Okay, how to detect outliers. Box plot. You can use box plot. So in anything above the maximum line, right? So anything below the minimum value also called as outlier. There are some values in the data which exceed usual values. This is shown by black circles, right? The black circles are called as your outliers. This is what the formula that we discussed, right, as part of descriptive study. We will be using it. And IQR you can find out. And right, so anything above this one is called your outlier. How to deal with outliers? Deleting observations, right? So in this case, we delete our values if it is due to data entry error, data processing error. We can also trimming at both ends to remove outliers. What we are doing is we are trimming both ends, right? So here we are trimming this way. And next thing is, you can do binning, right? So transforming variables can also eliminate outliers. Natural log of a value reduce the variation caused by extreme values. Binning is also a form of variable transformation, right? Here, see, the age is 0. Okay. Okay, here labels. Okay, let us say 0 means adolescent, and okay, 0. Okay, this is the index value. Okay, and I'm giving some labels for this one. Okay, adolescent, adolescent, young, 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 right? So these are the labels that I have given it for those indexes. Natural log reduces the variation caused by extreme values. Okay, binning is also a form of variable transfer. You can also use the process of assigning. So what I did here is anybody, right? So 0 to 15, right? So that is the thing I'm doing it here. And next one is imputation, right? So okay, what I would suggest you guys, it's you can try it out from here. Okay, these three we will continue from next session. So far we discussed about the outlier, various causes for outlier, intentional outlier, what is data entry error and measurement error, what is intentional outlier. This is a very interesting thing, right? Intentional outlier is something like, this is the example. In the interview they might ask you, probably you can tell this one as an answer. Teens are more likely to underreport the amount of alcohol they have consumed because they are scared. If they tell the fact, they will be punished by their parents, right? So, and also smoking, right? Teens are more likely to underreport the amount of cigarettes that they take it, right? So only a fraction of them will reveal the actual quantity. Here the actual quantity might look like the outliers, okay? Because rest of the teens are underreporting. Because teens, if you look at in this case, you will find very less number of teens are smoking or consuming alcohol. But whereas in reality they are taking too much because they underreported, right? We got into a situation called unintentional outliers, right? And data entry errors, mistakenly we have typed it instead of specifying it, right? Right. So if I specify by mistakenly removing one, I'm ignoring. I mistakenly I typed only 5 zeros instead of 6 zeros. I typed only 5 zeros after 1. Right. That is data entry error. Measurement error. 10 weighing machines, 9 of them weighing correctly, whereas one of the machine is faulty machine. Right. This is a measurement error. Right. So over a period of time, due to wear and tear, the machines may not function as expected. What are the various types of errors are possible which causes outliers? If you explain, at least 4 to 5, but sampling error also can cause your this is also one of the cause for your outliers. Okay, just go through on this. Okay, day 4 and day 3 exercise you go through on it, and also you complete it. We will circle back probably Thursday morning, same time. Okay, not probably, we will circle back for sure on this Thursday morning. Okay, and then we will continue with the missing values exercise. It is still pending. We discussed today what is the difference between loc, 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 iloc, ix operator, when we are supposed to use it, right? And also we discussed about the plotting techniques, right? So how to plot the box plot, how to use histogram, how to segment a box plot based on a specific column, right? All those things we looked at. How to plot the bar chart, bar plot, right? And then outlier, right? What is binning, right? All the things we discussed it. We'll continue discussing it from this Thursday. From next Tuesday onwards, we will continue with hypothesis testing directly. Okay, I will explain you the hypothesis testing concepts, everything. And then, or we will do one thing. Instead of getting into hypothesis testing, all the things, we'll directly jump into building the models. Okay, linear regression and logistic regression, everything. Okay. And then once I explain you the concepts of linear regression, logistic regression in Python, right? I will demonstrate you the same thing in R also. Okay. So that you will be gaining more understanding on building the algorithms also, machine learning algorithms. Okay. So hopefully May 15th, if you are in a good shape, right? May 15th or 20th. We can start prepare your profile, and we can take your profile, and probably I can share your profile through my network. And if you are interested to look out for a job, you can look out for a job, right? Otherwise, you can hang on till May 31st or so, right? So May May end I'll complete it everything, whatsoever may be the reason. Okay, I'll complete the entire course, so that you can look out for a job, or if you are already working with your current, I mean, if you want to continue with the same organization, whatever the skill set that you learned it, right, as part of this training, you can start practicing it on a day-to-day basis. So don't think, video is there, right? Okay, bye. We will meet up on this Thursday, same time. Okay, bye. Ankur, I would suggest you, if you can join by 9-10 a.m., it will be great, yeah. Yeah, you missed out all the, see, many of the things you learned, but it is a very comprehensive topic. Okay, see, this measurement error and sampling error, right? So natural error, and if you understand all the things, right, it will be very much helpful for you. Okay, just refer my, huh?
Basic idea about this, and after this I will go through that complete video.
Yeah, basic idea is there, but still comprehensively I covered here, right? So you should be able to tackle any type of questions around the outlier, right? If you go through on this, right? Fine. And again, you can answer the questions instantaneously, right? That way it will keep you. Okay. Okay. See you, and we will circle back on this Thursday morning. Okay. Bye.